Hello, and welcome to this brief presentation on polynomial division. Polynomial expressions. A binomial expression contains two terms such as p plus q, x squared plus 4, 7aq plus 3b squared, or 2x plus y cubed. A trinomial expression contains three terms such as 3x squared minus 2xy minus y squared, or x to the power 4 plus 2x squared y plus y squared. A polynomial is a mathematical expression consisting of three or more terms. The polynomial expressions are of the form function of x is equal to a plus bx plus cx squared plus dx cubed, etc. So the function of x is equal to x cubed plus 3x squared y plus 2xy squared plus y cubed. We need to note that the powers of x are decreasing from left to right and the powers of y are increasing from left to right. If we were given a function, say px is equal to 2x to the 4 minus 3x squared plus 6.5x minus 7, when we're going to undertake polynomial division, we must write it of the form 2x to the 4 plus 0x cubed minus 3x squared plus 6.5x minus 7. So the terms shown in the box for the x cubed must be added when we're undertaking polynomial division. You'll see why that's required in the examples that follow. Polynomial division. In general, polynomial functions of x are only made up of positive whole number powers of x, for example, x cubed or x squared, multiplied by constants and then added together. The order of a polynomial is given by the highest power of x. Note the following are not polynomials: x to the half, x plus 3 to the power of negative 1, sine x, log x. Essentially, polynomial division relates to long division in algebra. It's sometimes required when resolving polynomials into partial fractions. This can be particularly useful when helping to simplify functions that we need to integrate or when using Laplace transforms. Revision of long division using numbers. Those of you that are familiar with the process of long division using numerical values can skip the following few slides. For those of you that want to recap on how to undertake long division in a conventional manner using numbers, then the next few slides will help you recap that process. So using the following division sum, we can demonstrate how long division is undertaken using numbers. So we're asked to calculate 968 divided by 4 using long division. For reference, notice the numerator is sometimes called the dividend and the denominator is sometimes called the divisor. So we conventionally write our problem in this format. The 968 is divided by the 4. So what we do first of all is say how many times does 4 divide into 9. It goes twice, 2 times 4 is 8. So we write the 2 above the 9 in the dividend. So there's the 2. So we know that 2 times 4 is equal to 8. So we write the 8 below the 9 in the dividend. There's the 8 here. Now we're going to subtract the 9 and the 8. So subtracting 9 minus 8 is equal to 1, so we write the 1 here. Now we bring down the 6 from the dividend. So bringing down the 6, we write it here. Now 4 divides into 16 4 times. So we write the 4 above the 6 in the dividend. So here's the 4. Now we're going to subtract the two numbers again. So subtracting 16 minus 16 will equal to 0. That's effectively the value we have here. So nothing to write down in this case, but we're going to now bring down the 8. Bringing down the 8. So we brought down the 8 and written it here. Now 4 divides into 8 twice, so we write 2 above the 8 in the dividend. Here's the 2. Writing the 4 times 2 is equal to 8 here. We again subtract the numbers, and this time find the value is 0. So subtracting 8 from 8, we get 0. That means there is no remainder in this particular case. There's no value left here. So finally, the answer for our sum of 968 divided by 4 is equal to 242. That example shows you how the long division process is undertaken using numerical values. Here are some tutorial exercises I would encourage you to undertake. In exercise 1L, part A, we've got 208 divided by 16. In part B, we've got 186.375 divided by 5. And in part C, 9,845 divided by 3. The answers are shown here in the brackets. Notice with parts A and B, there are no remainders here. But with part C, there will be a remainder, and it's shown written in two forms, 3,281 remainder 2, or 3,281 and 2/3. Exercise 2L is a descriptive question. We're given the mass of 1 cubic meter of lead. It's approximately 1,100 kilograms. We're asked to estimate how many cubic meters will be required to produce a quantity of 50,000 kilograms. So basically the sum here is 50,000 divided by 1,100. Answer again shown in the brackets below indicate a remainder, and again the answer is written in two forms shown here. I would encourage you to start the presentation and attempt these exercises using the process shown on the previous slide for long division, but the full work solutions are shown on the following slides. Exercise 1L solution. Part A, we're asked to calculate 208 divided by 16. So again, as per the example on the previous slide, we write that as 208 divided by 16. So our procedure is, how many times does 16 divide into 2 completely? Well, it won't go. But 16 does divide into 20 once. So we write 1 above the 20 in the dividend. So here's the 1 above the 20. 1 multiplied by 16 is 16, so we write that below the 20 in the dividend. Here's the 16. And we subtract the values. 20 minus 16 is 4, so we write the 4 here. And next we bring down the 8 from the dividend. So we brought down the 8, and it's shown here. So 16 divides into 48 exactly 3 times, so we write the 3 above the 8 in the dividend. Here's the 3. So 3 multiplied by 16 is 48, so we write the 48 below, shown here. Then again, subtracting the values leaves 0. So again, no remainder. So in this case, the 208 divided by 16 produces an answer of 13. Exercise 1L solution for part B. We're asked now to calculate 186.375 divided by 5. So as shown previously, we write that as 186.375 divided by 5. Start our process. 5 divides into 18 completely 3 times. So we write 3 above the 18 in the dividend. Here's the 3. 3 multiplied by 5 is 15, so we write 15 below the 18 in the dividend. It's the 15. So subtracting here, the 18 minus 15 leaves us with 3, and we bring down the 6 from the dividend, shown here. So now, how many times does 5 divide into 36 completely? It goes 7 times. So we write the 7 above the 6 in the dividend, shown here. 7 times 5 is 35, shown here. and again we subtract the values. So subtracting 36 minus 35 is equal to 1, shown here, and we bring down the 3. So bring down the 3, shown here. How many times does 5 divide into 13 completely? It goes twice, so we write the 2 above the 3 in a dividend. So here's the 2. So 2 multiplied by 5 is 10, we write down the 10 here. Again subtracting, 13 minus 10 is equal to 3. We now bring down the 7, bring it down to 7, shown here. 5 divides into 37 completely 7 times, so we write 7 above the 7 in a dividend. Here's the 7. 7 multiplied by 5 is 35, so we write 35 here. Subtracting 37 minus 35 is 2, we write the 2 here, and we bring down the 5, shown here. Five divides into 25 5 times exactly, so we write 5 above the 5 in a dividend, shown here. 5 multiplied by 5 is 25, so we write that below here. And again, we subtract the values. So subtracting the values leaves us with 0, so again we've got no remainder. So the answer to the problem here of 186.375 divided by 5 is 37.275 exactly. Notice how the decimal place is positioned in the calculation above. Exercise 1L solution, part C. We're asked to calculate 9,845 divided by 3. So structuring our long division solution, that's 9,845 divided by 3. So how many times does 3 divide into 9? It goes 3 times exactly. 3 times 3 is 9. Subtracting the values leaves us with 0. Next we bring down the 8, shown here. So how many times does 3 divide completely into 8? It goes twice, and 3 times 2 is 6. Again subtracting, 8 take away 6 leaves us with 2. We bring down the 4 from the dividend. So how many times does 3 divide completely into 24? It goes 8 times exactly, write the 8 here. So 3 times 8 is 24. And again subtracting leaves us with 0. We now bring down our last number from the dividend, which is 5. How many times does 3 divide into 5? It goes once, so we write the 1 here, and 1 times 3 gives us a value of 3. Subtracting, 5 take away 3 gives a value of 2. No other numbers to bring down from the dividend, so the remainder now is 2. So we can write the answer as 3,281 remainder 2, or we could write it as 3,281 and 2/3. Notice the remainder is written over the divisor here, for the 2/3. Exercise 2L solution. This was a descriptive question, but basically the sum we're asked to calculate is 50,000 divided by 1,100. Notice we have some cancelling down to undertake here to simplify the problem. We can cancel 2 noughts on the top line with 2 noughts on the bottom line. So the actual calculation we're undertaking is 500 divided by 11. I'll let you this time work through a solution on your own to work out the answer. You should find the answer is 45 remainder 5 meters cubed as unit used, or that could be written as 45 and 5/11 meters cubed. Again, notice the remainder of 5 is written over the divisor of 11. Now let's look at long division using algebra. So we're going to apply exactly the same process as we did with the numerical questions, but now we're going to use algebraic terms. So this is an example of polynomial division. So we're asked to divide 4x squared plus x minus 5, which is the dividend, by x minus 1, the divisor. So we're adopting the same process as shown previously, but it's more complicated now because of the algebraic terms. So again, writing along division format, here's our dividend and here's our divisor. So we start this process by saying, how many times does x divide into 4x squared? In other words, how many times does x divide into 4x squared here? Now if it helps, you can actually write these terms like this. The 4x squared divided by x. And we can look for cancelling down, which we can see here, because this x cancelled with the squared to leave us with 4x. So in other words, how many times does x divide into 4x squared? It goes 4x times. And we write the 4x above the 4x squared in the dividend, shown here. If we now multiply the x minus 1 by the 4x, we will end up with 4x squared minus 4x. And we write that below the 4x squared plus x in our calculation. So here's the 4x squared minus 4x. As with the previous calculations with numerical values, we simply take away the term. So careful here, 4x squared minus 4x squared would be 0. And 1x, don't forget there is a 1 here, we don't write, but it's there. And 1x subtract negative 4x. So be careful here, 1x minus a negative 4x becomes 1x plus 4x. So that's where the 5x arrives from. So again, be careful when you're subtracting. We've got an x minus a negative 4x, that's double negative, so that becomes 5x. And we write 5x in the solution. Now we bring down the negative 5 from the dividend. So here is the negative 5. And we repeat our process. So how many times does x divide this time into 5x? Again, we can write this little sum on the right hand side of the board here. So how many times does x divide into 5x? Cancelling down, we can see it goes 5 times. So it goes 5 times, and we write the 5 above the x in the dividend. And this is the 5. Now multiplying the x minus 1, the divisor, by 5, we get 5x minus 5, which we write here. And again, subtracting the terms, 5x minus 5x is 0, and negative 5 minus a negative 5, careful of the signs there, that will be negative 5 plus 5, that becomes 0. So subtracting leaves 0, so there's no remainder here. So the answer to our problem of 4x squared plus x minus 5 divided by x minus 1 is 4x plus 5. For reference, here are some common errors that sometimes occur when performing polynomial division. So be careful with negative signs as highlighted on the previous example. So note when subtracting negative 4x from 6x, the answer is 10x. Shown here, 6x minus a negative 4x, that becomes 6x plus 4x, and that's where the 10x comes from. So be careful. Also, be careful when dividing polynomials, they can be quite confusing. For example, x to the 5 plus 3x squared minus 6x omits some of the powers of x. So when we write the polynomial down that we're going to undertake long division with, we must write it as x to the 5 plus 0x to the 4 plus 0x to the 3 plus 3x squared minus 6x. We must do that before we perform the long division process. You'll see how the above is applied in the following example. Here are some tutorial exercises related to long division using algebra. Part 1 of exercise 1p, rational divide 3x cubed plus x squared plus 3x plus 5 by the x plus 1. Answers are shown on the right hand side in the square brackets. Part 2, rational divide the x cubed plus y cubed by x plus y. And a hint in the question here is to write the dividend out as shown. Part 3, rational divide x squared plus 3x minus 2 by x minus 2. And finally, part D, rational divide 4a cubed minus 6a squared b plus 5b cubed by 2a minus b. And again, there's a hint in the question. I'd encourage you to stop the presentation and undertake the calculations here before looking at the solutions on the following slide. Exercise 1p, solution. Part 1, rational divide 3x cubed plus x squared plus 3x plus 5 by x plus 1. To write in our algebraic fraction long division, we have 3x cubed plus x squared plus 3x plus 5 divided by the x plus 1. Starting long division process, we say how many times does x divide into 3x cubed. So basically we have 3x cubed divided by x. So how many times does x divide into 3x cubed? It goes 3x squared times. So we write the 3x squared above the 3x cubed in the dividend. Now we multiply the x plus 1 in the bracket by 3x squared, and that produces 3x cubed plus 3x squared. There's a slight error on this slide, as this sign here should actually state positive, not negative, shown here. As always, we subtract the equations. So 3x cubed minus 3x cubed would be 0, and plus 1x squared, again don't forget there's a 1 here, minus the 3x squared produces negative 2x squared. Next we bring down the positive 3x. So now we say how many times does x divide into negative 2x squared. Again we can write that as negative 2x squared over here, and that's divided by x. So how many times does x divide into x squared? Cancelling down, we can see it goes negative 2x times. So we write the negative 2x above the x squared in the dividend. So multiplying x plus 1 by the negative 2x, we will get negative 2x squared minus the 2x. If we subtract the equations now, and again be careful of the signs, negative 2x squared minus a negative 2x squared become negative 2x squared plus 2x squared, so that's 0, so that'll be 0 here. And positive 3x minus a negative 2x, be careful, that becomes 5x. We finally now bring down the last term in the dividend, which is the positive 5. So now how many times does x divide into the 5x? So 5x divided by the x, cancelling. We can see clearly that goes 5 times, and we write the positive 5 above the positive 3x in the dividend. As always, subtracting 5x minus 5x is 0, in this case positive 5 minus the positive 5 is 0. So there's no remainders time. So the answer to the problem of 3x cubed plus x squared plus 3x plus 5 divided by x plus 1 is 3x squared minus 2x plus 5. Exercise 1p, part 2, solution shown here. Rational divide x cubed plus y cubed by the x plus y. Now there was a hint in the question that when we write out the dividend this time we should write it as x cubed plus the 0x squared y plus the 0xy squared plus the y cubed divided by the x plus y. And you'll see in the calculation below why we need to keep that structure. Starting the process, we say how many times does x divide into x cubed? Again, if you want to think of it like this, that's x cubed divided by x. And if we cancel down, the x there cancels with one of the x's here to leave us with x squared. So how many times does x divide into x cubed? It goes x squared times. We write the x squared above the x cubed in the dividend. We now multiply the x plus y by the x squared, and that produces x cubed plus x squared y, which is written here. Now subtracting the terms, we have x cubed minus x cubed, that will give 0 here. We have 0x squared y minus the x squared y, so that will be negative x squared y. Careful there with the signs. You can see why we needed the additional term of 0x squared y here. And bringing down our next term of 0xy squared. Now repeating the process, how many times does x divide into the negative x squared y? Again, we could write this up here as negative the x squared y, and it's divided by x. That's in the x squared on the top with the x on the bottom. We find the answer is negative xy. So how many times does x divide into negative x squared y? It goes negative xy times, as written here. Now factor in the x plus y multiplied by the negative xy, that will give us negative x squared y minus xy squared. And that's written down here. Subtracting again, negative x squared y minus negative x squared y is actually negative x squared y plus x squared y, so that's where we get 0 from here again. And 0xy squared minus the negative xy squared, be careful there of a change of sign, that leaves us with xy squared. We bring down the final term in the dividend. So repeating the process, how many times does x divide into xy squared? In other words, x y squared divided by x. We'll just show this calculation here for convenience. So the x in the denominator cancel with the x in the numerator to leave y squared. So how many times does x divide into xy squared? It goes y squared times. So we add the positive y squared term above the dividend. Multiplying the x plus y by the y squared produces xy squared plus y cubed, which we write down here. And we can clearly see subtracting xy squared minus xy squared is 0, and y cubed minus y cubed is 0. So again, we have no remainder here. So the answer to the problem of x cubed plus y cubed divided by x plus y is x squared minus xy plus y squared. Exercise 1p, part 3, solution. We're asked to divide x squared plus 3x minus 2 by x minus 2. So writing in division format, we've got x squared plus 3x minus 2 divided by x minus 2. So starting the division process, how many times does x divide into x squared? So on the right hand side, if I just put x squared here, divided by x, which is the sum we're asked to do, we notice we can cancel the x in the bottom with the squared on the top to leave us x. So how many times does x divide into x squared? It goes x times, which is right above the x squared in the dividend. If we now multiply x minus 2 by the x, we end up with x squared minus 2x written here. And as always, subtracting, x squared minus x squared is 0. And positive 3x minus a negative 2x, be careful of the double negatives there, that's 3x plus 2x, so that's 5x shown here. So now we bring down the negative 2 from the dividend, and repeat the process again. How many times does x divide into 5x? So 5x divided by x. Cancelling x in the numerator with the x in the denominator leaves us with 5. So we write 5 above the 3x in dividend. And then multiplying the x minus 2 by 5, we write 5x minus 10 here. Subtracting, 5x minus 5x is 0, and be careful here, negative 2 minus the negative 10, that's negative 2 plus 10, so plus 8. We cannot divide x into 8, so we now have a remainder equal to 8. So our final solution for x squared plus 3x minus 2 divided by x minus 2 is x plus 5 plus the remainder of 8 divided by the x minus 2. Just be careful how you've written that fraction at the end. Exercise 1p, part 4 solution. We're asked to divide 4a cubed minus 6a squared b plus 5b cubed by 2a minus b. So writing in our long division form, we've got 4a cubed minus 6a squared b plus, notice the 0, ab squared term here, plus 5b cubed, all divided by 2a minus b. So commencing the division process, we say how many times does 2a divide into 4a cubed? So 4a cubed divided by 2a. Again, if we look for cancelling, we can see that the 2 divides into the 4 twice, and then the a in denominator cancels with the cubed in the numerator to leave squared term. It goes 2a squared times. We write 2a squared here above the dividend. Multiplying 2a minus b by the 2a squared, we find we have 4a cubed minus 2a squared b. Subtracting the terms, 4a cubed minus 4a cubed will be 0. Negative 6a squared b minus the negative 2a squared b. Very careful here with the change of signs. That's negative 6a squared b plus 2a squared b. So negative 4a squared b. Then we bring down the next term in the dividend, which is actually 0 in this case, is 0ab squared. Commencing our process again, how many times does 2a divide into the negative 4a squared b? So negative 4a squared b, or divided by, in this case, 2a. But for cancelling here, we can see that the 2 again cancels into the negative 4. We go negative 2 times, and the a in the denominator cancels with the squared in the numerator. So how many times does 2a divide into negative 4a squared b? It goes negative 2ab. So we write the negative 2ab above the dividend here. Then we factor the 2a minus b by the negative 2ab. That produces negative 4a squared b plus 2ab squared. Subtracting, negative 4a squared b minus the negative 4a squared b. That becomes 0 here. And then the 0 minus the positive 2ab squared. Careful there, that's negative 2ab squared. Bringing down the last term in the dividend, the positive 5b cubed. And now repeating the process again, how many times does 2a divide into the negative 2ab squared? So negative 2ab squared divided by 2a. We cancel here, we can clearly see the 2a in the bottom line cancel with the 2a on the top line. So how many times does 2a divide into negative 2ab squared? It goes negative b squared times. So we write the negative b squared on the top line here. Subtracting the terms, negative 2ab squared minus the negative 2ab squared becomes 0. And positive 5b cubed minus a 1b cubed, don't forget we have a 1 here, becomes 4b cubed. We cannot divide 2a into 4b cubed, so the remainder is 4b cubed in this case. So dividing 4a cubed minus 6a squared b plus 5b cubed by 2a minus b, the answer is 2a squared minus 2ab minus b squared plus our remainder of 4b cubed divided by the divisor of 2a minus b. Here are some tutorial questions I would strongly encourage you to attempt, all related to polynomial division. The answers are shown on the right hand side in the square brackets. Just note in question 5 that negative one simply means dividing by x plus y. That's a reciprocal index notation. The tutorial questions continued. Again, we're asked to solve the following problems with polynomial division, but only the remainder part is stated in the answer below. Here's the bibliography used to help generate the presentation. And I hope this has been of interest to you, and thank you for viewing.